larger animals feed on fish, and complex web foods emerge. Coral reefs, open waters, and coastal ecosystems all depend on this steady input of solar energy. But this balance begins to collapse surprisingly quickly. Below roughly 200 meters, sunlight weakens to the point where photosynthesis can no longer occur. This marks the beginning of a vast mid-ocean region known to scientists as the twilight zone. Here, there are no plants, no forests, no sunlight-driven food production. Life survives on what falls from above. Tiny particles drift downward constantly, dead plankton, waste, and organic debris. This slow rain of material is known as marine snow, and for the creatures of the twilight zone, it is the primary source of energy. In this dim environment, visibility becomes dangerous. Many twilight zone animals have evolved bodies that are nearly invisible. Some are so transparent that their internal organs are barely noticeable. Squid and octopus species appear more like drifting glass than solid creatures. Scientists are still debating why transparency is so common here. It may reduce visibility in low light, it may save energy by eliminating pigmentation, or it may serve both purposes at once. Whatever the reason, transparency offers survival advantages in a place where being seen often means being eaten. Not all creatures choose invisibility. Some animals generate their own light through a chemical process called bioluminescence. In the deep ocean, light is not decoration, it is a tool. Bioluminescence can attract prey, signal to mates, confuse predators, or erase a silhouette entirely. One particularly clever adaptation is known as counter-illumination. Animals produce light along their undersides that matches the faint glow from the surface above, effectively erasing their shadow when viewed from below. Others use light in more deceptive ways. Certain jelly-like creatures glow in deep red wavelengths that most deep-sea animals cannot see. To predators, these animals appear completely dark, even while consuming glowing prey internally. In the deep ocean, survival often depends on who can control visibility and who cannot. Each night, something remarkable happens. As darkness spreads across the surface, countless animals rise from the depths towards shallower waters. Fish, squid, and jelly-like organisms move upward to feed under the cover of night. By morning, they sink back down again. This daily movement, called diel vertical migration, involves more animals than any other migration on the planet. It remained unknown to humans during sonar operators during World War II discovered a mysterious layer in the ocean that rose and fell each day. That false seabed turned out to be life itself, moving together on a massive scale. Below 1 kilometer, sunlight disappears entirely. This is the midnight zone, a region of perpetual darkness, near freezing temperatures and crushing pressure. Here, evolution takes unusual turns. Some predators have developed skin so dark it absorbs nearly all incoming light, rendering them almost invisible even under artificial illumination. Others, like certain dragonfish, produce red bioluminescence, a color most deep-sea animals cannot detect. This gives them a private light source to hunt prey without being seen. Reproduction also becomes extreme. In some species of anglerfish, tiny males permanently fuse with much larger females, ensuring reproduction in an environment where encounters are rare. Life in the midnight zone follows rules unlike anything on the surface. At around 4 kilometers deep, the seafloor spreads into the abyssal plain, a vast, flat expanse covering more than half of Earth's surface. It is cold, dark, and nearly devoid of food. Yet life persists. Many abyssal animals grow to surprising sizes, a phenomenon known as deep-sea giantism. Giant isopods, massive crustaceans, and enormous squid roam these depths. Why size increases here remains uncertain. Larger bodies may conserve energy, store resources, or deter predators. Occasionally, a rare event transforms the abyss: the fall of a whale carcass. These massive inputs of food create temporary ecosystems that can support entire communities for decades. Specialized organisms, including bone-eating worms, extract nutrients locked inside skeletons long after the soft tissue is gone. In the deep ocean, life moves slowly. Growth is gradual. Reproduction is rare. Lifespans stretch far beyond what we see on land. Some deep-dwelling sharks may live for centuries, making them among the longest-lived vertebrates known. Even the sediment itself is alive. Microscopic organisms recycle nutrients grain by grain, sustaining a hidden food web beneath the seafloor. The abyss may appear empty, but it is anything but lifeless. Beyond the abyss lie ocean trenches, places where tectonic plates collide and the seafloor plunges to extreme depths. This is the Hadal Zone, reaching nearly 11 kilometers below the surface. Pressure here is immense, yet life exists. Snailfish with soft, flexible bodies inhabit the deepest known environments. Their cells contain specialized molecules that keep proteins functioning under extreme pressure. Smaller creatures like amphipods swarm the trench floor. Disturbingly, even these remote habitats now contain traces of plastic pollution, evidence that no part of the ocean is truly isolated from human activity. In certain trench environments, life depends not on falling debris, but on chemistry. At hydrothermal vents, superheated water rich in minerals pours from the Earth's crust. Microbes convert these chemicals into energy, forming the base of ecosystems completely independent of sunlight. These discoveries have reshaped our understanding of where life can exist and have expanded the search for life beyond Earth to icy moons that may harbor similar hidden oceans. Despite modern technology, most of the deep ocean remains unexplored. Each expedition reveals species never seen before, organisms with unfamiliar shapes, unfamiliar chemistry, and unfamiliar strategies for survival. The deep sea is not a static place. It is a dynamic, evolving world that continues to surprise us. And perhaps that is its greatest lesson. Even on our own planet, vast realms remain unknown, waiting to be understood.
The deep ocean remains one of the last unexplored frontiers on Earth, and we are only beginning to understand what lives there. Every new discovery reminds us how much of our planet is still unknown and how important it is to protect these fragile ecosystems before they disappear. If you value real science, verified discoveries, and true stories from the depths of the ocean, consider supporting this channel by subscribing, liking this video, and sharing it with others who are curious about the natural world. Your support helps bring more documented deep-sea discoveries to light and ensures this exploration continues. Thank you for watching, and stay curious.